Section 1.5 is about a way of finding inverse matrices. And we do this by looking at row operations and then defining some new types of matrices. Well, I mean, they're still matrices, but a different way of looking at them called elementary matrices. So anyway, let's first of all start with our elementary row operations. There were three of them that we had defined earlier. You can multiply any row of the matrix by a non-zero constant c. You can interchange two rows, and you can add a constant c times one row to another row. Actually, let me end that here, to another row. So you multiply one row by a constant and add it onto the other. These were the three elementary row operations, and what they did was they changed the matrix, but when we interpreted a matrix as the augmented matrix of a system, that these operations didn't change the solution set to the system. So it allowed us to solve systems. Okay? But these are all elementary row operations are going to help us do a lot of other things too. One thing I want to note is that each of these elementary row operations is actually an invertible thing. That is, if you start with a matrix and you multiply one row by, say, 7, is there a way to get back to where you started from? Well, of course. You could just multiply by the multiplicative inverse of 7. Multiply a row by the reciprocal. And if c was non-zero, then 1 over c is also non-zero. So you can undo multiplying a row by a constant. Likewise, we can undo interchanging two rows. And the way we interchange two rows is we could interchange the same two rows again. If I swap rows 3 and 4, and then I swap rows 3 and 4 again, then I'm back to where I started from. This isn't keeping up with me. Interchange the same two rows. And lastly, how do I undo adding a constant, multiple of one row to another? So if I, let's say, multiply the first row by 3 and add it to the second row, how would I undo that? And it turns out what you can do is you can just multiply the first row by -3 and add it on, right? So what I want to do is I want to add a constant. All right, here we go. -c times one row to another. I'm going to actually write it as the other, because I'm referring, the is referring to the same row as we had before. So each one of these elementary row operations has a corresponding elementary row operation that undoes it. I mean, each of these is an elementary row operation. We just do it again, or we multiply by a different constant to get us back to where we were. Okay. So in this way, we can see that if you have a sequence of row operations that takes matrix A, you've got a sequence of row operations that keeps transforming it into matrix B, then there must be a corresponding sequence of elementary row operations that could get you back. Each one of these things could be undone by this sequence. So in this way, we make the following definition. We say that A and B are row equivalent if there's a sequence of row operations that transforms one into the other. If there is a sequence of row operations and I don't have to say which one goes to which, because if it goes one way, it goes the other way, right? So they're row equivalent if there's a sequence that goes from one to the other. Okay. Now, what I'm going to do is I'm going to find a way to represent these row operations and perform these row operations by matrix multiplication. So what we're going to do now is make another definition, and we're going to define an elementary matrix. Right. An n by n matrix is called elementary this is getting annoying. It's called an elementary matrix. It's called an elementary matrix if it can be obtained by performing one elementary row operation to an identity matrix. So let's give you some examples. So for instance, if I look at the matrix 2, 0, 0, 0, 1, 0, 0, 0, 1, that matrix I can think of as it came from a 3 by 3 identity matrix, or I multiplied the first row by 2. That is an elementary matrix. Okay. How about something like this? Let's do another 3 by 3 example. I'm going to do 1, 0, 5, 0, 1, 0, 0, 0, 1. If you think about the 3 by 3 identity matrix with all ones down here, and then I say take 5 times row 3 and add it to row 1, then I get this matrix. I perform one row operation on an identity matrix, and I get an elementary matrix. Let's do one other 3 by 3 example while I'm here. How about something like this? 1, 0, 0, 0, 0, 1, 0, 1, 0. This would be starting with a 3 by 3 identity matrix and swapping rows 2 and 3. Okay. An elementary matrix. There's 3 types of elementary matrices because there's 3 row operations. Start with an identity, multiply one row by a constant. You've got an elementary matrix. Or start with an identity, add a multiple of one row to another. You've got an elementary matrix. Start with an identity matrix, swap 2 rows. You've got an elementary matrix. Okay. So these elementary matrices are what we're going to use to do a whole bunch of stuff this quarter. They help us get a handle on performing row operations, as we'll see in the next video.